Hello students, today we are going to study one of the most important topic in physics, that is vector, which is utilized everywhere. Like in majority portion of mechanics you will be utilizing in solving the problem electrostatic, you will be utilizing, even in solving the problem of electromagnetic induction you will be utilizing, okay. At many places you will be utilizing the concept of vector. So dear student, what is vector? In this chapter we will study vector, vector properties, vector classification, addition, subtraction of vectors, parallelogram law of vector addition, polygon law of vector addition, triangle law of vector addition, vector multiplication like scalar product, vector product and properties, okay, and related problems. So first of all, let us start from what is vector. Vector quantities. A physical quantity having both direction and magnitude. A physical quantity having both direction and magnitude and satisfy triangle law of vector addition, then the physical quantity is called vector quantity, okay. Like force, torque, momentum, displacement, all are vector quantity, okay. Dear student, if a physical quantity having both magnitude as well as direction but do not satisfy triangle law of vector addition, then the physical quantity will not be a vector quantity. For example, electric current. Electric current has both direction as well as magnitude but do not satisfy triangle law of vector addition. So electric current is not a vector quantity, okay. Now we will study various types of vector, okay. So let's study vector classification. One by one I will teach you all types of vector, like polar vector, axial vector, and how the vector. First of all, you should learn vector representation. Vector representation. Dear student, a vector is represented like this. Putting this arrow. Here, the length of the line, the length of this line indicates magnitude of vector. And direction of arrow on the line on line, this arrow indicates the direction of vector. And this point is called tail and this point is called head. So the direction of vector is from tail to head, okay. Now let's see. We can write vector like this also. Suppose this direction is east, this direction is west, this direction is north, and this direction is south. Dear student, if a vector is having angle 45 degree, means if the vector is at the angular bisector, okay, then we can write the vector like this. Simply you can represent like northeast or east north, or you can write this north 45 degree of east, or you can write 45 degree north of east, or you can write east 45 degree of north, or you can even write 45 degree east of north. Okay, so you can understand whenever any vector makes angle 45 degree, you can represent vector like this. For example, if the vector is making 45 degree angle here, you can represent vector like northwest only. If the vector is making 45 degree angle here, you can simply write southwest. And if the vector is making 45 degree angle here, you can write southeast. Okay, this is how we represent the vector. Okay, but dear student, if a vector is not making angle 45 degree, okay, then how to write the vector? Okay, this is very important for solving the numerical problem, because if you do not understand the vector notation, then you cannot solve the question. Okay, so let's see. Suppose this is east, this is west, this is north, and this is south. Let us assume the vector is making angle 30 degree. Okay, then how to write this vector? Because this vector is making angle 30 degree with the east or 60 degree from the north. Okay, so the procedure to write this, we can write north 30 degree of east. This of will be written with the letter from which the direction is there, from which the angle is there. Okay. Or you can write this to be 30 degree north of east. Okay, since this same vector is making 60 degree angle with the north, so you can write like this: 60 degree east of north. Or you can write east 60 degree of north. Okay, now hope you can write any vector. For example, if the vector is making here 37 degree angle, how to write, how to represent? Very simple. Now we can write this south 37 degree of west, or this angle is 53 degree, we can write west 53 degree of south. Whatever is the angle, the of letter is written with the particular direction, that angle will be there with that direction. Okay, so this is how a vector is written. Okay, now dear student, we will be studying vector classification. Vectors can be classified into following category. Let's see. One is collinear vector, which will again be classified as parallel vector and anti-parallel vector. Which will again be classified as equal or same vector, and here opposite or negative vector. displacement and position vector. Unit vector, this is very important vector. Axial vector, polar vector, coplanar vector, so dear student, this is the broad classification of vector. Let's see what is collinear vector. Okay, one by one we will be looking. First see parallel vector. Any two vector are said to be parallel vector when their direction is same, magnitude may or may not be same. Magnitude may or may not be same. A vector and B vector are said to be set of parallel vector when their direction is same and magnitude may or may not be same. Okay. So here angle between, this we will study later. Angle between two parallel vector, dear student, is 0 degree. Okay. Here theta is the angle between two parallel vector. If magnitude of two parallel vector is same, then they will become equal vector. Okay, so let's learn about the equal vector also. Two vectors are said to be equal vector when their direction is same and magnitude is also same. Then vectors are said to be equal vector. So dear student, you can say all equal vectors are parallel vectors, but all parallel vector may or may not be equal vector. Okay, because equal vectors will be having same magnitude as well as same direction. Okay, and the parallel vector will be having only same direction. Magnitude may or may not be same. Okay, angle between two equal vector or between two parallel vector is 0 degree. Okay, later on when we will be studying unit vector, okay, I am writing here one thing, because this type of problem you will be seeing in the lectures. Okay, if a vector is written like this, a1 I cap, this we will study little later, a2 j cap plus a3 k cap, where I cap, j cap and k cap will be unit vector in x, y and z direction, and b vector equal to b1 I cap plus b2 j cap plus b3 k cap. Dear student, if a vector and b vector are set of parallel vector, if a is parallel to b vector, then this condition will be satisfied. Coefficient of I cap, j cap, k cap and the ratio will be same, means a1 upon b1 will be equal to a2 upon b2 will be equal to a3 upon b3. So you can solve, if two vectors are parallel vector, you can find the missing, okay, missing term. Now dear student, we will be looking for anti-parallel vector. As the name indicate, anti-parallel means which is not parallel, which is opposite to parallel. Okay, two vectors are said to be anti-parallel vector when their direction is opposite to each other and magnitude may or may not be same. and angle between two anti-parallel vector is 180 degree. Two vectors A vector and B vector are said to be anti-parallel vector when their direction is opposite to each other and magnitude may or may not be same. Now we are looking the special case of anti-parallel vector, that is opposite vector or negative vector. Okay. Opposite or negative vector. Dear student, two vectors are said to be opposite vector when their direction is opposite to each other and magnitude is same. Two vectors are said to be opposite or negative vector, then their direction is opposite and magnitude is same. So you can say all opposite vectors are anti-parallel vector, but all anti-parallel vector may or may not be opposite vector. Now dear student, what is collinear vector? All parallel vector, equal vector, opposite vector, anti-parallel vector are a set of collinear vector. Collinear vector means vectors which are in the same line, maybe parallel or maybe anti-parallel. Okay, are set of collinear vector. Okay, hope you understood collinear vector, parallel vector, and anti-parallel vector. Now we will be looking for position vector and displacement vector. As the name indicates, what is position vector? Any vector that will indicate the position of a particle at a given instant is called position vector. The position vector depends on the reference frame chosen. And what is displacement vector? Displacement vector is the final position vector minus initial position vector. Dear student, displacement vector do not depend on the reference frame chosen. Okay. Before studying position vector and displacement vector, let's see unit vector. Okay. This unit vector is very, very important in vector chapter. Dear student, as the name indicate unit vector, if vector is there means direction magnitude will come. Unit vector means its magnitude is 1. So any vector can be said to be unit vector if it has a direction magnitude and magnitude equal to 1. And what is role of unit vector? It indicates the direction of given vector. How to represent unit vector? See here. The unit vector is represented by small letter putting cap over here. And unit vector is defined as vector divided by magnitude of vector. This can be written like this also. So dear student, any vector can be expressed as vector equal to magnitude of vector multiplied by unit vector in the direction of vector. Any vector can be written as magnitude of vector multiplied by unit vector in the direction of vector. Okay. In practical purposes, we have considered I cap, j cap, and k cap are unit vectors along x, y, and z direction respectively. So dear student, unit vector in minus x direction will be minus I cap, unit vector in minus y direction will be minus j cap, and unit vector in minus j direction will be minus k cap. Okay. And how to calculate now? Let's see one more thing. Dear student, if any vector A is written like this, A1 I cap plus A2 j cap plus A3 k cap. The magnitude of this vector is written like this. This we will see little later. This A1 square plus A2 square plus A3 square under root. Okay, this will be the magnitude of vector. If any coefficient is negative, then also no problem. When you will make a square of the negative, then it will become automatically positive. So dear student, now we will solve a simple problem to find the unit vector. Okay, let's see a question. Suppose vector A is like this, 2i cap plus 3j cap plus 4k cap. Then find unit vector in the direction of vector A. So we can easily write this is vector 2i cap plus 3j cap plus 4k cap, and its magnitude is 2 square plus 3 square plus 4 square, which can be written as 2i cap plus 3j cap plus 4k cap divided by 16 plus 9, 25, and 4, 29. So dear student, this is what? This is the unit vector in the direction of vector A. This is the equation of unit vector in the direction of vector A. Okay. So this is how we can solve the problem of unit vector. Now let's see one more illustration. A force of 20 Newton, a force of 20 Newton is acting at an angle 37 degree with the east direction. Then find the equation of unit vector. Okay, very simple. Dear student, first make the vector component, write the equation of force vector. This is 20 cos 37 degree I cap plus 20 sin 37 degree j cap. Dear student, this will give us 20 cos 37 degrees 4 upon 5 and sin 37 degree is 3 upon 5. So after solving this, we will get this cancels by 4, this cancels by 4, 4 into 4, 16 I cap plus 12 j cap. Now let's see about the unit vector. What is unit vector? This is 16 I cap plus 12 j cap divided by under root 16 square plus 12 square. Okay, or you can simplify the equation like this. Take 4 as LCM. Okay, so force vector can be written as 4 4i cap plus 3j cap. Now it is very easy to find unit vector. Vector divided by magnitude of vector, 4 multiplied by 4 square means 16, 3 square means 9, 16 plus 9 25, under root 25 means 5, 4 4 will get cancelled, so answer will be 4i cap plus 3j cap divided by 5. This will be the unit vector in the direction of the given force vector. Okay, this is the equation of unit vector in the direction of given force vector. Okay, now dear student, we will see about the position vector and displacement vector. Position and displacement vector. Any vector which represent the position of a particle is called position vector. Let's see, a bird is here, 8.234 with respect to this origin. Write the equation of position vector. It is very simple. Now equation of position vector of bird can be written as 2 minus 0 I cap plus 3 minus 0 j cap plus 4 minus 0 k cap. Okay. So equation of position vector of bird is 2I cap plus 3j cap plus 4k cap. Dear student, this is the equation of position vector of bird. Okay. Now let's talk about the displacement vector. Displacement vector can simply be written as final position vector minus initial position vector. It does not depend on the reference frame chosen. Suppose the position of a particle initial position is at 1, 2, 3 and the final position becomes 4, 6, 9. Particle gets shifted from point A to point B. Then write the equation of displacement vector. So directly you can final position vector minus initial position vector 4 minus 1 I cap plus 6 minus 2 j cap plus 9 minus 3 k cap. So dear student, this will be 3 I cap plus 4 j cap plus 6 k cap. This is the equation of displacement vector. When we will be seeing triangle of vector addition or something like that, we will see in more depth. Okay. Now let's see what is coplanar vector. Coplanar vector means vectors which are in the same plane. Okay. For example, 2ik plus 3jk and 3ik plus 6jk or 3ik plus 4jk. These vectors are in xy plane. Okay. So vectors which are in the same plane are called coplanar vector. Now dear student, what is polar vector? Polar vector means a vector which has a fixed starting point, okay, which is called polar vector. Axial vector, these vectors will be utilizing in rotational motion like torque, angular momentum like that, which has direction in the direction of rotational axis are called axial vector, like angular velocity, angular displacement, angular acceleration, torque, all these are axial vectors, okay. Now dear student, we will be looking for some important properties of vector. Important properties of vector. For example, the most important property is shifting of a vector. Most important property is shifting of a vector. Every vector has two things, one is magnitude, another is direction. When a vector is shifted parallel to itself without changing its magnitude, when a vector is shifted parallel to itself without changing its magnitude, then vector do not get changed, okay. This is how we can shift a vector from one place to another place. Let us see. Suppose this is vector A. We can shift this like this. Shift it parallel. Now again shift it from this place to this place. Now again shift it from this place to this place. When a vector is shifted parallel to itself without changing its direction and magnitude, then vector do not get changed, okay. This is how we can shift. Now dear student, we will be telling you about the how to calculate angle between two vectors. This is also very important thing. Angle between two vectors, the angle between any two vector is the angle between tail to tail or between head to head of the vector. Angle between tail to tail or between head to head of vectors is the angle between two vectors. For example, here is a question, let's see here. Suppose this is vector A and this is vector B and angle is here theta. And we have to find angle between vector A and vector B. This theta is not the angle between vector and vector B, because this theta is the angle between tail and head, okay? So what you have to do, either you shift vector A or shift vector B. You can do anything, okay? Now dear student, if we are shifting vector B, we know how to shift it parallel. Since this angle was theta, so this angle will be how much? This angle will be 180 minus theta. So angle between vector A and vector B is 180 degree minus theta in this question, okay? Or you can find like this also. What you do? Keep vector B here. Now shift vector A, okay? This was vector B. Now shift vector A. Since this angle was theta, so this angle will become 180 minus theta, okay? So you can find angle between any two vector, either edge between tail to tail of the vector or edge between head to head of the vector, okay? So dear student, in the next lecture we will be looking for component of vector, that is resolution vector in a plane, okay, and in in a space, okay? And also we will be looking for triangle law of vector addition, polygon law of vector addition, and parallelogram law of vector addition, and we will see lots of problems, okay, to understand the key concept of vector. Thank you very much.